I would like to take advantage of this short video to clarify some of the confusion that you may have during the class today. The question asked is that how does it actually go from e to the power minus sat times the Laplace transform of e to the power minus at and times sine of omega t plus omega. So this is something like everyone's like, oh, it's very new. In fact, it's not. How is it that we're going to go from this step to this step? And again, if if you have no clue at all how this is going to convert, the hardest way to go through it is actually going through this integration function of the f sub s equal to integration from 0 to infinity, small f t multiplied by e to the power minus s times t with respect to dt. So the red part is actually represent the part that you have to multiply for this integral in order to go from time domain to the frequency domain here. So we don't want to do that, to do this conversion, because there's a trick that we can actually handle this by going through the trigonometry identity. So that's what I'm going to explain this next for the next page. So from this you can see that you probably will recall from your calculus 2 is that sine AB is equal to cosine A times sine B plus sine A times cosine B. Likewise, cosine A plus B will be equal to cosine A times cosine B minus, this time, sine A times sine B. So to do this Laplace transform on this sine omega t plus omega, actually we simply apply this equation sine plus AB. So if you write in the way that we want for omega t plus omega, it will be equal to cosine omega t times sine omega plus sine omega t times cosine omega. So what you can see here that I put it in specifically in the red color is that that represent constant, because we only care about converting from the time domain to the frequency. So this is part that relevant to the Laplace transform part. And if I may write this to the original equation, it will be Laplace e to the power minus at multiplied by the whole thing here, which is I write here, and then what you do is you do the expansion from my multiply e to the power minus at to this first term, and then the second term, which result in the next line. So here you go. Now you see that there's a red color part represent the constant, and the black color represent what you have to look up from the table 13.1, which I think this is no stranger to you. So you can see that this part is actually represent this part, and then this part is actually representing this part. So the red part remain the same as it is, but the conversion simply using that table 13.1 from the last two, you have the cosine that result with s plus a, because you have the minus a here, and then s plus a to the power of 2 plus omega squared, plus cosine omega multiply the same thing for cosine. You have the constant here omega, and then you have the plus a in this time s plus a to the power of 2 from that table. Hope this helped.